Today we're going to be talking about looking at patterns in linear functions. A lot of what we do in Algebra 1 is going to be talking about lines and how they kind of work and how they fit into our lives. With patterns, a lot of patterns we look at in math. Now outside of math, and we discussed this a little bit during class, was we see patterns everywhere. Whether it's, we look at patterns in the weather. We like to see that, what the forecast is. A lot of people that like money look at patterns in the stock market or what the market's doing, trending up, trending down, looking to buy low and sell high to make a lot of money. There's bees in nature that use patterns. They use hexagons rather than circles to store their honey in the honeycombs. And that's to maximize efficiency of space, so they can keep the most amount of honey for themselves. Trees use patterns, and plants use patterns, the weather patterns, when it's colder and there's less sunlight, where the leaves fall and they get ready for winter, so they can start all over again in spring. And there's patterns in our bodies, in our faces. There's a lot of symmetry in our bodies, and different patterns with like the difference between like your hairline and your eyebrows to your nose to your chin, different patterns like that. That subconsciously we look at every day. So patterns are a big part of life. And it's no different than in math. But before we get into looking at graphs and thinking about these variables and how they go, there's some definitions we need to be aware of. The first one is an independent variable. This is a variable often denoted by the variable x, or the letter x, whose variation does not depend on that of another. This is also known as the input value, and this is what we start with. This is what comes first. So if we're looking at a graph, the independent variable is always on the bottom. This is what we start with. This is what can stand alone. The second variable is the dependent variable. This is often recognized by the letter y. This variable whose value depends on that of another. This is the output value, and this is what we finish with. This cannot stand alone. Right? We need to start with the independent variable first, and then the dependent variable. The dependent variable is what gets listed here with the y values on the graph. So we're given some words, some vocabulary words, to our x and y values. The relation. A relation is a pairing of numbers in one set. It starts with the input value and ends with the output value. So we're going to see something, and usually as an ordered pair of x comma y. A function. This is really important. Star this. Many students confuse this, mess this up on standardized tests, and forget about what the definition means. It's a relation in which each input value, so each x value, has exactly one output value or one y value. If there is a relation in which an x value repeats with a different y value, it is not a function. Most of the things we talk about are functions. And finally, linear function. This is a function that, when graphed, creates a line. There is a constant or consistent change with the x values and the y values. And we'll see that in some of the examples we look at. So the first example we look at is this. Which table represents a function? A or B? The first one or second one? Now, this first one is not a function. And this is why. This 4 repeats. It goes, the output is 2, it's also 3. That's why it's not a function. Not a function because the 4 repeats. Whereas the second one, this is a function. 1 and 6, 2 and 6, 3 and 6, 7 and 6. None of the x values repeated. So this is a function because no x value repeats. And again, this is important in math, and a lot of times in problem solving, a lot of times once you have one thing, it can never equal different things. And it's important to be able to identify if it's a function or not. So again, if the x's repeat, it is not a function. Example 2. We want to start kind of looking at graphs and seeing how these are related. So we look at this, number of packs, number of hamburger buns. When these are listed in a table, we go alphabetical order. This is X, this is Y. Okay? Now, as you can see, these are going up by 1s, these are going up by 8s. Now it's easy to, if we don't have numbers on our graph, we want to kind of be creative. We're going to make the bottom ones going up by 1s. Because our x's are going up by 1s. That's pretty easy. Over here, we can't make this 1, 2, 3, 4, 5 all the way up because we don't have enough room. Okay? We want to create different intervals. And we want to make sure these lines are the same spacing apart. I'm going to pick going up by 5s. You could do any other number, but it's easy to count by 5s. We have to make sure that the whole graph, all these points, fit on our graph over here. And now we plot them. 1 goes to 8, which is about there. Okay? Somewhere between the 5 and the 10. 2, 16. 3, 24. 5, 32. And then finally, 5, 40. Now we've plotted points before. This isn't too bad to handle. Now we have some questions to answer. First of all, is this function a linear or nonlinear function? A nonlinear function would be anything that makes a curve. So if we look at this, all the points, it looks like it's lining up in a line from just eyeballing it, but we can make sure it does. And how we can make sure something is linear is to see the changes between the x and y values. If we notice, going from 1 to 2, we're adding 1. 2 to 3, adding 1. Adding 1 each time. There's a consistent increase here. If we look at our y values, there's a consistent increase here as well. Each time we're adding 8 to it. Now this, being that these are all 1s and these are all plus 8s, this tells me that this is definitely linear. Now it asks, what's the independent variable? We want to start with the x values. The independent variable is a number of packs. The dependent variable is the number of hamburger buns. And then how are these two related? Again, I always start with the x values. As the packs increase by 1, and we're going to add a little bit of detail here. Okay. Increase by 1. The amount of buns increases by 8. And we can describe what's going on in this graph. So as the packs of buns increase by 1, the amount of buns increases by 8. And we can look at that because we can see those numbers increasing. Here's example, the next example. Now here I might change up my scale a little bit. Here it's going up by 2s. I think I can still stretch this out to make it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can. This is going up by up to $4. Maybe here I go up by 50 cents. Going up to $4. Okay? And we can graph these. When the cost is, when the weight is, over here we have cost. Sorry, my computer got a little messed up. And we have weight here. So the weight, when it's $2, when we have a weight of 2 pounds or 2 ounces, the cost is 80 cents. When the weight is 4 ounces, we're at $1.60. When we're at 6 ounces, we're at $2.40. We're at 8 ounces, we're at $3.20. And then we're at 10 ounces, we're at $4. Now again, this looks like a linear equation. And it is. Here we're increasing by 2 each time. And here we're increasing by 80 cents each time. Everything is the same. So this is another linear equation because we're increasing by 2 in our x's and 80 cents in our y's. Our independent variable, again, is our weight. Our dependent variable is the cost. And again, we can't have any costs unless we're paying for it, we're getting something. All right? The weight can stand alone, cost isn't. How are these two variables related? As the weight increases by 2 ounces, the cost increases by 80 cents. And as the weight increases by 2 ounces, the cost increases by 80 cents. And we can write it that way. And here's the last one. Right here, the number of photos we're starting with is, so 0, 1, 2, 3. I'm going to kind of skip here. So the number of photos is down here. The memory is on the left. And we're going from 512 and 503. So I might start here. I can kind of start this at maybe 490, 495, 500, 505, 510, 515, 520, and so forth. So when we're at 0, and again you see I don't have to start always at 0 here. I can kind of start this and make it a different range. 512, so I'm going to start right there. 509, down just a little bit here. 2 and 506. 3 and 503. Again, this would be a linear equation. It looks like it's making a line, it is. This is going up by 1. This is actually going down by 3. Still the same. The change is just a negative instead of a positive. So again, here's our independent variable is photos. The independent variable is memory. And it kind of makes sense. The more photos, the less memory we'll have. And for every photo we take, our memory decreases by 3. By 3 megabytes.